today, we're gonna be building a new and improved Geiger counter with a Fallout type aesthetic. So you can kind of see I've already 3D printed the stuff off and made sure it fits up, because if it doesn't, it takes way too long to re-3D print. I did realize that it kind of messed up and unstuck this corner, which leads it looking a little gimped, but it'll be fine. It also has a little bit of a rough surface finish on this. I think that this was like 1 degree crooked on the print bed or something. Listen, I sent this stuff to print late Sunday night at like 3 a.m. and I think that maybe I messed up some slight details, but given that we're going for a grungy aesthetic, I'm not too concerned. I printed out these nice little accent lines that I'm gonna glue in place. A lot of this is gonna end up getting glued together, but it doesn't need to be too weather hardened. The fact that it's in a pretty big shell is gonna be good enough. You can see the general vibe that I've gone for here. You have your little accent lines here. You have your, you have this front panel, which doesn't have any holes in it, because I wanted to actually be able to drill these. So this is printed 100% infill. And we'll be able to drill holes for like an on switch and whatever other indicators we end up want. And then this guy bolts onto the front here, and this holds our Nixie tubes, which are already soldered into this nice little board with these Soviet-era decoder chips. And if you're questioning their Soviet-era-ness, if you look at the marking on the chips, you can actually see that there's some Cyrillic on there. Anyway, I haven't done much with Nixie tubes on stream before. I'd like to be able to do some more stuff. We'll see how well y'all like this project, basically. You know, we're always trying new stuff here. And if you guys find this one fun, then I'll try out some other Nixie tube things. But basically, the way this is gonna work, these guys are binary decimal decoders. So there's 4 input bits here, and that's what these wires connect to. There's 4 input bits on each one of these for each of the digits. You send it the number that you want to display on the Nixie tube in binary, and then you connect the high voltage here that goes to each of the tubes. And this is able to sync the like 170 volts DC to ground. So that's why these are special chips. They're not just a standard binary to decimal decoder. They have to be really high voltage because the Nixie tubes are high voltage. Now, this guy here is this was our power supply for the Nixie tubes. And I, a fool, on Sunday when I scheduled this stream, thought that this still worked, but apparently it does not. I don't know what fried on it. I've been poking around it with the multimeter. I can't figure out what it is. Something on here fried, and now it doesn't output 170 volts DC anymore. Now, I am wondering, because I could swap, like, the MOSFET for the switching circuit. That's, like, a potential point of failure. But it could also end up being one of these chips, and I don't have replacements for those. So what I've done is I've looked up on the internet, and I found a simple circuit using a little 555 timer as an oscillator, and a 100 microhenry inductor, which we'll get to how we have to get that one working. But using those two things, a decent power MOSFET, which I have, and a basic switching transistor, we can basically make a new Nixie power supply. So this is the thing that's actually going to display the CPM on the Nixies. This has already been confirmed working. I've connected some debug LEDs here. It outputs the numbers properly. That works. All we need to do is get it in there and power it. This is our split power supply, so we come in with 12 volts off of a LiPo cell. This splits it down, 12 to the step-up converter, 5 to the driver chips, because that's what they run on, and then 5 to the Arduino that's going to be driving the driver chips. That all works as well. This, as far as I know, still works. The circuit itself works. If one of the chips is fried, I have some backups. So, though, we're also covered on that. Basically, what I'm trying to get to is the main risk of today's project is getting the fucking power supply for the Nixie tubes working, because apparently my pre-made one is fried, and thanks to delivery backups, even though I discovered this Sunday night, the soonest one could get delivered to me a similar module is next Saturday. So we got to deal with what we got right now. Oh yeah, the way that this is designed, because you'll see it a little more here, is that you have your display up here, and we'll go ahead and bolt this little shroud cover here. You have your controls here, handle here, that's why it has the cutout, so you can grab it. And then on this, I'm using this little XLR port, that's gonna come off a cable, which then connects to this guy. There'll be a cord that comes out of this hole, and this is gonna be where the actual Geiger counter lives. So you'll be able to bring the Geiger counter closer without having to bring the whole assembly, right? Like the actual counterpart is gonna be separate. It's gotta be separate from the rest. That's the idea anyway. Hopefully this works out well. Let's actually separate our power supply from our Geiger counter circuit here. Hopefully the Nixie driver works, because I really want the Nixie tubes to be able to fire during this stream, and if they don't, I'm gonna be sad. There we go. See, I had to have this cut out because the tube needs to be exposed. So, this will allow us to have our tube, whoop exposing the tube. This will allow us to have the tube sticking out of the box, and we can get it close to our radioactive sources, which we'll get to that. The tubes come in any other colors? Nixies? Nah, they all glow orange. They all glow orange because that's a physical property of how they work. I don't know, you could probably like phosphor coat. I think they had some VFD stuff that glows green, but I've never seen a Nixie tube that's in like this style that glows green. This is support material, so I'm just getting rid of it. Yeah, there we go.
Are you still browsing the web with no protection? That's not just reckless, that's straight low-tier behavior. Tired of being lumped in with the IP block, geofence data harvested peasants? A sin. Get thee a Proton VPN. Brought to you by the same privacy fanatics who made the email client every whistleblower and paranoid uncle swears by. Over 15,000 servers in 120 countries means you can fake your digital passport faster than you can say unblock Netflix library. High speed, no throttling, works from anywhere. Trapped behind the Great Firewall or some other government's killjoy filter? One toggle and poof, you're posting from Florida with a bald eagle on your shoulder. Think the three-letter agencies are building a file on you because of your galaxy brain takes on obscure forums? They might anyway, but Proton VPN's audited no logs policy means your real IP will never be the smoking gun. Court order? They open the logs and it's just tumbleweeds. 100% open source apps and infrastructure, because real privacy doesn't hide the receipts. And for a limited time, they're doing 75% off yearly plans, so act now to save big. Go to protonvpn.com/uoslab to learn more and lock it in before you regret it. Huge shout out to Proton VPN for sponsoring the madness. Now back to the video.
Fake metal mesh over the Geiger tube? That is a great idea, actually. Hang on a second. I wish I had some real metal mesh. Oh, wait, actually, no, we can't use a... Hang on, we can't use a metal mesh because it would block, it would mess up the readings. It would block some of the radiation. Fallout London? Oh, yeah, I've heard of Fallout London. Fallout London is basically... Okay, I understand the frustration, but I mostly just know about Fallout London because they were infuriated that the devs of the real game didn't give them a heads up that they were gonna update the base game. And it's like, why would they update a mod team? But I don't know, man. Maybe some game devs are nice enough to update, to let their popular mod teams know about updates. Funny stripes to glue onto this box, too. I'll take the Geiger counter off. But this one, I have these gray. It's the same type of deal, except they're gray. The idea is that it's like it's a textured grip. I think it adds a lot of character. I could make this one yellow instead. I don't know. Maybe I should go print some yellow ones. A lot of people don't. Yeah, you can just buy uranium ore. It's not illegal to own uranium ore. Now, if you start refining it, I think there's some three-letter agencies that'll have a word with you. But just owning the ore is not illegal in any way. All right. Before we can really start messing around with this guy, We need to make our power supply. So let's get started on that. I mean, everything radioactive people freak out about, but like you would basically not affect any amount of your life if you ate off of uranium glass on a regular basis. It's not a whole lot of radioactivity being emitted. This is the article that I'm going off of, and this is the schematic that we're following. Very clever little LRC circuit driven by a 555 oscillator. This shit should run at 9 to 12 volts and output about 170 volts, which will drive the Nixies. So hacker can you could tell it was built around, they really didn't want to risk someone hacking your oven and burning your house down. I understand why they don't why they don't want that. What magazine is this? I don't think it's a magazine, it's from a blog. And also it talks about it like, oh, you're provided this and this and this. So I think they sold this as a kit at some point. So I was gonna say, if we just needed 170 volts, pop in one of these cheapo ZVS drivers that I've got kicking around, run that into like one stage of a Cockcraft Walton, 1 or 2 stages, and that shit gotta get us up pretty high. Because this thing outputs like, I don't know, like, oh no, wait, you need a flyback. Whoa, you couldn't use a flyback either, that'd be too much. But will it fit in the case? Probably. It's way overkill. You need to make the world's weakest flyback transformer. It's probably just not be worth it. I'm getting too in the weeds here. But it's just a circuit I understand better. This is the main appeal here. This guy might be our ticket. This is from some of these storage things I have, because some of them are my own sets of stuff. But then, like, I don't know, 15 years ago now, I bought a bunch off of some guy who was like, yeah, I actually don't like this hobby anymore, and I have all these parts. So I was like, oh, do you not want them anymore? I'll take them off your hand. Now I have a bunch of parts. This is an inductor. What is this? 3R9K. That's the right form factor. Doesn't mean it's the right one. Voltage regulator. Not really what we're after. Why around? This might have the specific transistor types he was calling for. Never hurts to have random spare parts. That's what I'm saying. Occasionally when I need to dig around for something that I don't keep like normal stock of, I can find it in this guy's stash, because he has all sorts of weird stuff. It's like, why does he have this many types of transistors? I guess because it's useful to have. Wait, is this 555? You can tell this is my box. Look how many components I have. Look at this thing. This is a USB-B connector, but you know why it's like black and looks like it got dug out of the dirt? A lot of these components, I got them by taking old electronics that people threw away, and I'd put the circuit board with the components down and then torch the back with a propane torch while whacking it against the ground, and all the big components would fall off. So that's why that's how I have like these little USB-B connectors and stuff. Oh wait, there's a 555 right here. Perfect. Finally, we found something on our component list. 5 IRF, we got like an equivalent. 547, is that the PNP or the NPN? Recycling, hell yeah. I remember I torched a chip off of a board, and then I sold it on eBay for $10. But it was like, it wasn't like a inline package where it was like easy. It was a fucking like QFP package chip, and the guy bought it and then he messaged me like 3 times where he's like, can you give me specs on this? Can you give me any details on this chip? And I didn't answer because I didn't know anything about it. I'm still baffled to this day why he bought the thing. No one ever bought any of the scrap parts that I was trying to flip. You can swap it for a 2-in 2222. Of course I got those. That's like one of the OGs. Here, let me get that other container real fast. That's fine as hell. Should fit well, even with the guy in here too. Look at that, man. And it shouldn't block much. It should still be fully readable through the mesh. Yeah. 3D printers are quick these days. Yeah, it's pretty good. It's a pretty nice little printer too. We need to glue these guys into place. 555's output directly drives a high voltage MOSFET that switches the current through the inductor. The FET is on, current flows to ground. As the current in the inductor builds up, the FET then turns off. When the FET turns off, the current flowing through the inductor tries to continue flow but can't flow through the FET, so the voltage on the FET's drain terminal rises. So the ultra-fast diode D1 becomes forward biased. This allows the energy contained in the coil to be dumped into the high voltage capacitor C4. So that being high voltage is actually quite important. The cycle continues until the voltage across C4 reaches a value set by the trim pot. You know, now that I'm going through all this, originally I was like, it'll be better to just build a new one than to try to fix the old one. But as I look at how hard it's gonna be to get this working and how many components I have that are not to the requested spec, maybe. Yeah, these old, I think you guys need to realize vacuum tubes ran on like 100+ volts because they operate using like charge potential. And you need a lot of electricity to actually trigger that. So you would have a low voltage supply going, which would run individual heating elements in your tubes to heat them up, and then you would have your higher voltage ones for your actual like stuff. Okay, this is 12 volts DC in. You can see the little LED turns on. I don't know if you could see that well, but on our output, we don't see anything. Unless it decided to fix itself while it was stored away last night. Nope. Nothing at all. I'm not sure where the failure point is. Because, like, it's not the transformer. That shit will work forever. It's got to be one of the discrete components. But I'm not really sure which discrete component it is. This thing uses two an LM393 and an LM... Sorry, this is a UG384. 3843. I think those are both op amps. What is it using the op amps for? That's your likely point of failure is the op amp? Wait, it is. Hang on, wait. There's AC output on this thing? 138, 120, 120. Wait. Do you know what's probably fried? Do you know what it is? I bet it's this. I bet it's this guy right here, this big diode. That's probably that probably rectifies it down. The AC output. I mean, this is a transformer. Like, I think that how this is getting the power is it's stepping up the voltage using this transformer. So this is all oscillation and like protection, and then that pumps it into the transformer, which then steps it up into steep AC output. Yeah, it's 170 reading on this. Wait, we are getting output on this side. Wait, what? Wait, did I just make it work? Hang on, wait. Wait. I think I poked something and made it work. Because now DC on our output is reading hundreds of volts. It's reading 216. Y'all, I think we might have just lucked into the solution. I think we maybe got lucky. Because it seems like it just works now. Hang on. Question mark, it works now. Pogface.png. This is what's gonna plug into the two blue wires coming off the power supply, is gonna be this guy. I think I'm gonna stuff the power supply, this power supply, way down here in the corner. I don't know, because I need to be able to stuff a battery in here too. This is a fucking colossal case. Like, if you look at this, it's huge. And it should have no problem whatsoever fitting all the components. But as I'm actually looking at it, I'm realizing that we kind of are going to have some trouble fitting all the components. Hang on a second. Wait a second. Does this actually close? Oh my gosh, it barely closes. Barely, if at all. Dude, the Nixie tubes are kind of too long. They barely fucking fit. What the hell? Those things are... Oh, man. That barely closes. Print a spacer? Well, unfortunately, this part that sticks up that has the connector on it nests into this part. So you can't print a spacer. You'd have to print a whole bottom. It does close, but it barely closes. Hang on a second. I'm going to try to route these wires. I did not use nice flexible wires when I originally wired this up. These are all hard bell wire. You gotta share some of that chewing wire, or do I gotta get my own wire to chew on? I think it might be on your own, buddy. What the fuck? What output? Wait, what? What combination of these outputs when you click the button? That's the combination. I see. You expected more than flea market knockoff specs in something that I'm building? I don't know what to tell you, brother. I already taped over the bottom of this board so it couldn't short out. So, at least we got that going for us here. We are gonna have to connect it to this module that I already programmed. That's gonna need 2 voltage lines from this, which I just realized have both broken off. Fantastic work. Yeah, this is where they were supposed to be. Why did those break off? Luckily, this guy hasn't broke off. Not yet, at least. This is our Nixie power line. This got blocked, but I do see that at UO's lab, flurries are using you. Isn't that the fucking ice cream treat at McDonald's? How am I being used by the McFlurry? I had to drill a step bit through this to put a toggle switch to turn the whole thing on or off. That's the last... Try to pack this in here in a way that it is minimally obstructive to the lower tier. And I'm also gonna need... I just realized, though, I need to connect this ribbon cable first. Alright. I don't know how this, like, is gonna work. Do we strap this to the back? Dude, it is crazy how much space I thought I had in this thing, and now how fucking crammed it is. Look at this shit. Okay. Looks like no smoke immediately, at least. Oh! Yes! Alright, the Nixie drivers work. You love to fucking see it. It's so funny you have to press the button to turn the drivers on. Yes! Okay. Confirmed working on lab power. No fire. Yeah, we're looking pretty good, bros. Now we just need to be able to cram a battery in here. Let me see if I have a 3S that isn't big, because I don't really want to cram this guy in there. He doesn't fit anywhere that I can see. These wires take up way too much space. I could step 2 4S's down into... I'll use this one for power, because I want to reduce the chance that I accidentally send power down the wrong hatch. There we go. Easy. That toilet precision. Okay, wait, that works. That works with the Arduino. Wait, can I actually close it? Hang on, that maybe works. I think the Arduino might stick up a little too high there. If it can nest like that, we're actually so Gucci. We can cram the battery here, and then everything just fits and it works, and it's all sunshines and rainbows. It's all sunshine, rainbow, white pony all the way down. You know, I didn't check to see if the level of the Geiger counter is actually detectable by the Arduino, because if it's not, I'm gonna have to do some level shifting tomfoolery, which would suck really, really bad. Dude, the Arduino sticks up so far, it's not even fucking close. It sticks up like over a centimeter. This shit needs to be like crammed in the side, like this. Yeah. It's also gonna need some hot glue or something sticking this. Not waiting for the gun to heat up again for this. That's the Fallout way to use hot glue. Have you guys seen that? You guys seen that Reddit post of the guy that was like, saw this dude literally opening a can with a knife the other day. Thought it was an epic DayZ reference. Turns out he was just homeless. Dog. I think I need to make this thicker. I think I literally, and this wouldn't be done during this stream for obvious reasons. This shit don't fucking close, bro. Look at this. It's so close. Yeah, but I'm afraid I'm gonna snap it in two if I try to force it. And I don't want to do that. This should still work. Whoa, it's detecting all sorts of crazy shit. I guess there's nothing hooked up to it, so it doesn't know what to think. This is why we abandoned the chat gimmick that uses Nixie tubes. Because you can't, like, they look good in person, but they kind of look awful on the stream camera, unfortunately. You can kind of see them here, but it's pretty hard. Let's see if this just works. If it just works, we are truly Todd Howard maxing. If this functions straight up as it is right now, it'll be actually insane. And this is plugged in. This is supplying 5 volts to this, so it should be good. I forgot I had to do that. They're all initialized to 0. Dude, it actually tanks the screen so hard now when you turn this light off. Hang on. Okay, so that means it is properly pulling this up. Let me do it this way. This way it doesn't fucking tank the frame rate. All right, yeah, you can read the display. You can see that it's ticking a little. I don't know if that's enough for it to measure. Let me get my sample. Dude, where the hell did I put my uranium? Where did I put my fucking uranium? Use the Geiger counter to find it. It's not that long range, bro. It's not that radioactive. You have to get pretty close with the counter to actually tick it. Where? You guys need to understand, it is always in the exact same place, and I barely ever touch it, so it's really baffling, like, as to where it could even go. Where could it have possibly ended up, man? Not on the desk, that's for sure. Did I drag it out? Guys, you're not gonna fucking believe this. It was out in the garage. Let's see if this actually counts. I don't think the signal's strong enough for this to register it. So hang on a second. I'm gonna tick you off for a second. I can't believe the uranium was in the garage. Dude, I was losing my mind. I thought that we had somehow, like, ultra lost the thing. Let's reconnect power here. Oh, that triggers it. Oh, wait, maybe it doesn't. Nope. Fuck! Okay, hang on a second. Do I need some... What kind of fucking circuit can read this thing, dude? Alright, this is our set, though. This is our Geiger counter. This is our... With this handle, where this is the detecting part. I should turn the light on for actually showing it off. This is the handle, and this is the detecting part. This turns on the Nixies. This turns on and off the actual detector. The Nixies use a decent amount of power, so it's actually nice to have that. And then this cable loops around to the detector. Now, I'll turn off the lights to make it look easier. But, there we're reading all zeros. Now let's get our uranium up in here. This isn't super radioactive, so maybe it won't be able to detect through the gray. Nope, there we go. It's able to get some of the clicks through. Let's drop the threshold down. Can we drop it to like half? I feel like it would really make it easier to detect if I drop the threshold to half. It's just a matter of if it's gonna be detecting radiation when there is none. And it looks sick, too! All the custom enclosure and everything. Like, dude, it looks great. We didn't even need this extra panel, but I've got it just in case. Alright. The button that turns it on fitting in the thing. Alright, we'll turn that off so you guys can actually see the Nixies. And then, yeah, it does more accurately count it now. There we go. Yeah, okay, that's more accurate. As I said, the uranium isn't that radioactive unless you put it, like, right up on the thing. Oh, there we go. 400, 415, 456, 54. Okay. I was gonna say, because you can see the little LED here. Maybe you guys can't see it, so we're going, and it, like, alternates, because there's a little bit of randomness to it. I wish I had the X-ray blaster. That would be a great test, because that absolutely bombards it, and it would probably go over the limit. Dude, that's sick, though. We fucking did it. It works, man. That's crazy. Once this is fully assembled, is it going in the keep pile? Yes. Yes, because I used the Geiger counter. And that's why I said I'm going to print a wider back for it, because I want this to be a permanent thing. I actually want to be able to use it as a Geiger counter.